5.7 we talked about how to graph these functions, how to find the domain and range for them, how to talk about the transformations, all that stuff. So on number 1 it says graph using a chart and then identify the domain and range of each function. So on the quiz I gave you the points, but let's think about what points we would plug in there if you weren't given them.
0.
Good, so the smallest thing that you can put underneath that square root is 0. So I would start there. So I would plug in a 0. And then what would be the next perfect square that you could plug in? 1. And then after that? 4. Good. So then I want to plug each of those in. So this would be the square root of 0 minus 3, which is 0 minus 3, or negative 3. And then that last box, I want you to give the x that you plugged in, which is 0, and then your result, which is negative 3. And then I will plug in the 1. So the square root of 1 minus 3, 1 minus 3, which is negative 2. So I plugged in 1, and I got negative 2. And then the last one, which would be 4, square root of 4 minus 3, 2 minus 3, which is negative 1. Everybody with me so far? Questions? All right, so now what do I do with those points? Plot them on my coordinate plane, right? So 0, negative 3, be here, 1, negative 2, and 4, negative 1. And we know square roots have a little bit of an arc to them. The positive square root is going to point to the right, just like ours says. All right, and then let's talk about domain and range. So remember, domain's the x. How far left and how far right does this go? So what's the first x? 0, and our arrow points to the right, which tells you that the domain would be x, where x is greater than or equal to 0. And the range is the y values. So what's the lowest value or the smallest y on this graph? Negative 3. And then it's going to keep getting bigger, so it'd be greater than or equal to negative 3. All right, so then the bottom, or number 2, says use the graph of f of x equals the square root of x as the guide and describe the transformation and the graph of the function. So we know the parent function would start at 0 and it would point up and to the right. What's the negative on the front of that 2 do?
Flip it.
Flips it where?
Across the y.
It flips it over the x. So it's going to flip it so that it's upside down, right? If it's inside, it flips it left or over the y. What's the 2 doing to this graph? Stretch vertically. And it would be by 2. So it's twice as high.
If it was a 2 inside the radical, would it be a compression of 2?
It'd be a compression of a half.
Oh, yeah.
Yeah.
Okay.
Yeah. The minus 3 underneath, what's doing that?
Right 3.
Good. Right 3, and then the plus 1 on the outside, up 1. So we're going to put all of that together. So I take my 0, which is at 0, 0, and I shift it up into the left or right first. But you could go left or right and up, it doesn't matter. So I know I'm going to end up going to the right 3 and up 1. This is my starting point. I know it's stretched vertically, which means it's going to be taller, or as though there was a string to it and pulled top to bottom, which is going to make that taller. But this time it flipped upside down. So it's going to be upside down, and each point will be twice as, in this case, low, because it's flipped upside down. Questions on any of it? So again, we touched on about if the negative was underneath, it would switch it over the y, so it would be pointing left. And if it was a number underneath, now that's going to it's going to either stretch it or compress it horizontally instead of vertically. Okay, this one says use the description to write the quadratic function g based on the parent function of f of x equals the square root of x. So that shouldn't be quadratic, that should be square root. The parent function is f of x equals the square root of x, and x is reflected across the y-axis, stretched vertically by a factor of 2, and translated to the right 5 units. So if it's across the y-axis, what does that mean? The negative's inside. So I know I'm going to start there. It's going to have a negative x on the inside of the square root. Stretched vertically by a factor of 2.
So a 2 on the outside?
Good. 2 on the outside. God bless you. And translated to the right 5 units.
Negative 5.
Good. So I'm going to actually put that parentheses on the front of the x like that, so that I know that the negative 5 is referring to my horizontal shift. And then this would just be equal to g of x. Yep.
If we didn't put that on the quiz, like the parentheses between the negative and
So I went easy on the quiz. Yeah. Questions on any of that warm-up? Okay. So 5.8, which is the last section that's going to get covered on your test, is called solving radical equations. So it's taking your square roots, all the properties of square roots that you're dealing with, and it's going to be setting them equal to something, and you're solving. So the good part is this is a lot of algebra skills. Like we go back to just solving for x. That's the kind of concepts here, okay? And there's some inequalities mixed in here too, which is the greater than, less than, all those symbols. So let's start with some of your basic skills. I'm going to give you a couple minutes to work on this. This is the background knowledge that you need to keep going, and hopefully this is some of the stuff we remember from 5-6. All right, so let's start with number 1. So the directions say simplify each expression and assume all the variables are positive. So when you look at number 1, you're adding square roots. Can I add these two square roots together? What's the rule on adding square roots?
They have to have the same number inside of it.
Good. Not only do they both have to be square roots, but in order to add or subtract them, I have to have the exact same number underneath. So because one of these is a 27 and one's a 12, I cannot. Okay? But what can I do with the square root of 27? Good. So when I break down 27, it's 3 and 9, which is 3 and 3. With me so far? So then what's the rule? How many do I need to go to the outside? 2. So if I can cancel out 2 3s, then 1 3 goes to the outside with the 2 that's already there. They're going to get multiplied together. So on the outside is 6. And then the 3 that doesn't have a match is going to get left over underneath with the x. And there's only one x, so that can't get brought to the outside either because I need at least 2 in order to bring one to the outside. Good so far? All right, then I have the 12. So the 12 can break down to 2 and 6, which is 2 and 3. And I have 2 2s. One's going to come to the outside with the 3. So on the outside is 3 times 2, which is 6. And then the square root, the 3 is left underneath, and the x is underneath. And I end up with 6 square root 3x plus 6 square root 3x. So now they both have the exact same root, right? Square root 3 and square root 3. All I have to do is combine the number in front. So this would be 12 square root 3x. So the root doesn't change just as though it was a variable. If that was 6x plus 6x, the x would stay the same, and I would add what's on the front of it. So the same thing is going to happen here. In order to do that, they have to have like terms, though. If that was a 6 3x plus a 6 2x, I couldn't combine it. They would get left exactly how it was. Okay, 2 square root 72y to the 5th. So 72 can break down into what two numbers? 8 and 9. 8 would be 2 and 4. 2 and 2. 9 would be 3 and 3. So I've got 2 2s. So I'm going to bring 1 to the outside. And I have 2 3s. I'm going to bring 1 3 to the outside. So the outside of my root has a 6. And there's a 2 left underneath, which means the inside has a 2. And then, do you remember the rule on how to figure out how many go to the outside when you've got an exponent on a variable? Divide the index. So what's the index? What's that little number on the front of this square root? It's 2, an invisible square root. So 2 goes into 5. How many whole times? 2 times, which means I'm going to bring out 2 y's. And how many are left underneath? 1. So the visual breakdown on that is this is 5 y's, right? Y times y times y times y times y. So I want to take them out in groups of 2's. 2 y's, that means one goes to the outside. Another 2 y's, a second y that goes to the outside. This y doesn't have a match, so it stays underneath. And then y times y would be y squared, which is where this comes from. Questions on that one? Yep. Uh-huh. So once you break them apart, like 27, let's say, right? I got 3 and 9, and then that breaks down to 3 and 3 again. So I've got 3 3's, but they come out in pairs. So 2 of them come to the outside of a root as 1. So I cancel out 2 of them. That means there's still 1 left underneath. And then there's an x to the first underneath. There's only 1 x. It doesn't have a match, so I can't bring it to the outside. It has to stay underneath.
So leftover 3 just comes under the square root?
Yep. If it doesn't have a match, it stays under. Does that make sense?
And then for the second one, you just put it because there's no other number.
Same thing. I took 12 and broke it down to 2 and 6 and 2 and 3, right? So 12 is 2 times 2 times 3. And there's a pair of 2's. That 2 came to the outside, and the single 3 that's left underneath stays under. So anything that doesn't have a match is going to stay under. Okay, so now let's think about when I've got variables involved. So this underneath x plus 2 to the third power means what? Is that x to the third plus 8? No, this is x plus 2 times x plus 2 times x plus 2, right? And that's 3 of them. So if I cube root that, what happens? I get just what's x plus 2. So the root on the outside and the root on the inside, if they match, they eliminate each other. And I'm left with just what's underneath. Okay, 4, I've got 2 times 48. So I can multiply that out and then break it down again, but I'm still going to just break it down, so I might as well leave it as it is. 48 would be 2 and 24, which is 2 and 12, which is 2 and 6, which is 2 and 3. Now the 2's get canceled out in pairs, right? So this is a 1 pair of 2's. I'm going to bring in 2 to the outside. A second pair of 2's. Second one goes to the outside. And then I've got this 2 left over that doesn't have a match. And I have the 3 left over that doesn't have a match. So underneath here is 2 times 3. And the y that doesn't have a match. So it stays underneath. So on the outside is 4. And on the inside is 6y. Questions on that one? Yep.
So you just put as many pairs of 2's on the outside?
Exactly. As many pairs of numbers that you can get on a square root. So if it was a cube root, I would need 3 of each number. If it was a 4th root, I'd need 4 of each number, whatever the little index is. Okay, and then these are writing the expression in radical form. So remember, and most of you got this right on the quiz. I think there's like one I think I found where we reversed it. Remember, what happens to the bottom number in the exponent? Slides to the left. So this becomes 2 root x plus 6 raised to the first power, which is the square root of x plus 6. And then for 6, this is the 5th root of 3y plus 4. And I can either raise the whole thing to the third power or just what's underneath. Both of these answers would be right. So remember, the bottom slides over to the left and the top drops down to become the exponent. Okay, so a radical equation is what we're doing now, which is just an equation that contains a variable within a radical. So it's an equation, meaning it's got an equal sign somewhere on it. And you're obviously going to be dealing with radicals, so you're going to get a square root. So to solve a quadratic, you would normally square root both sides of an equation. Now we're doing the opposite. We're going to solve a radical equation, which means we raise both sides to a power. So you're doing the opposite. So if it's a square root, I would square it. If it's a cube root, I would cube it. If it's a 4th root, I would raise it to the 4th power. Okay, so remember, for a square root, the index is 2. If there's nothing on that root, then that is implied at 2. So your job here is to isolate the radical. So in the first example, I've got the cube root of x minus 2. I would add 2 to the other side first, so that I've got the square root by itself, or the cube root in this case by itself, which is what it means by isolate it. And then if it's a cube root, I want to raise it to the power of 3, but whatever I do to one side of the equation, you have to do the other side. So by cube rooting, or by cubing a cube root, I'm going to cancel out the root on the left-hand side, and then 2 times 2 times 2 is 8. Okay, so you're just raising it to the power that would cancel out the index. It's a whole goal here. If it's not there, then it means it's a square root. All right, so we'll do the first couple with you. All right, so solve each equation. So I want to first isolate the square root. So for A, how do I isolate the square root? Subtract the 5 from both sides. I'm going to subtract it here and here. And I end up with the square root of x plus 1 equals 11. So now my root is all by itself. How do I get rid of a square root? Square it. So I raise this whole side to the power of 2 and this side to the power of 2. And what happens when you square the square root? Cancels out. So on the left is x plus 1, and on the right, 11 times 11 is 121. And then how do I solve for x? Subtract the 1. The best part about equations is every single one of these questions can be checked, right? If I take that 120 and plug it back in to the x, I get the square root of 120 plus 1, which is the square root of 121, which is 11, and 5 plus 11 is 16. So every single one of these problems can be checked to make sure that you're right. Questions on that one? Yep.
And can you do, I'm gonna do the one you did the square.
So you want to do something that's going to cancel out the square root, right? We want to get rid of that square root. So the inverse to a square root is a square. To get rid of something that's square rooted, we would raise it to that power. So if I'm square rooting, there's normally a 2 on the front, right? Like the index is hidden. If that's a 2, then to get rid of it, I have to multiply it times itself, which is squaring it. And then whatever you do to one side of the equation, you have to do to the other side.
So you're just trying to get rid of the radical.
Exactly. Yep, and then solve it from there. All right, so now I get 7 times the cube root of 5x minus 7 equals 84. How do I isolate that cube root? Divide by 7 first. So this side, the 7 is going to cancel out. I get the cube root of 5x minus 7. And 84 divided by 7, 12. Good. Now I've got a cube root. So how do I get rid of a cube root? Raise it to the third power. And whatever I do to the left, I have to do to the right. So this becomes 5x minus 7. This becomes 12 times 12 times 12. So 12 times 12 is 144. 144 times 12, 8, 8. Thank you. Whatever he just said. 1,000. I'm sure he didn't use a calculator. He's just that smart. Yeah. Now what? Add the 7. And then divide by 5. So this would be 3, 4, 7. No. Yep. No, I do. I'm going to push you to multiply numbers together. Yep. Well, you want to learn before Thursday or Friday. And divide numbers. Okay. So, yeah, we're in high school, algebra 2. We're not in 3rd grade. We should be able to multiply numbers together and divide without a calculator. Sorry, guys. No, you can't use a calculator on this stuff on the test. No. But well, Miss Meadows was wrong. I don't know what to tell you. All right, so what's the first step to isolating the square root in C? Subtract the 4, and 5 minus 4 without a calculator is 1. Look at you. You guys are so smart. Okay, now if I want to get rid of the square root, what do I do?
Square.
Square both sides. What is 1 squared? You're going to make it. Oh boy. 1 times 1 is 1, right? And then I have to do what? Add the 1. All of this without a calculator. See how pretty that was?
That was like an easy.
Yeah, they're not all going to be hard. All right, how about D? This time I've got a cube root. How do I get rid of the cube root? You cube both sides. And we just said 2 times 2 times 2 is 8. Magical brain power. Add the 4. 8 plus 4 is. And divide by 3. Questions on any of those? Okay, so now I've got a square root on either side of the equal sign. Is there a way to isolate it so that both sides don't have any other number besides the square root? What happens if I divide the right by 3? It's just going to end up with the 3 on the other side, right? So there's no way to isolate it so that neither of them, you with me? Right? I can move that 3 from the left to the right, but I'm still going to have something outside of a root. Yes? Does that make sense? Okay, so if that was not the case, if it was a numbers on one side without the root, then I would just divide by 3. But when there's a root on both sides, how am I going to cancel it? You got to square both sides. But that 3 is part of what's being squared. So I have to square this whole side, and I have to square this whole side. So on the left, the square and the square root cancel out. I get 7x plus 2. But on the right, that's 3 squared times the square root of 3x minus 2 squared. So what is 3 squared? 9. And then what is the square root of 3x minus 2 squared? 3x minus 2. So you're going to square whatever's in the outside of it and get rid of the square root from the other part. Now, if this was step 1 and we were just solving this equation, what would you start with? Good. Distribute that 9 into both. What's 9 times 3? 27. What's 9 times negative 2? Negative 8. Subtract the 7x. Add the 18. And divide by 20. Okay, so for A, I've got square roots, right? Can't isolate them, so I do what? Square both sides. So the square on the left is going to cancel out the square root. I end up with 8x plus 6 equals. And on the right, 3 squared is 9. Square root of x squared is x. And then all I've got to do is subtract the 8x from both sides. So it's canceled from here. And I get 1x, or x equals 6. How about B? This time you've got a cube root, right? So I've got to do what to both sides? Cube them. So this is going to get cubed, and this is going to get cubed. So the cube root of the x plus 6 cubed is going to cancel and just give me the x plus 6. And on the right, I've got 2 times 2 times 2, which we said was what? 8. And then the cube root of x minus 1 cubed would cancel out. And then I've got to distribute in the 8, the x minus 8. Got to get both x's to the same side. So I'm going to subtract the x from the left and the right. Add the 8. 7x equals 14. Divide by 7. And x is 2. Questions on those? Raise your hand if you got both of them right. Raise your hand if you got at least one right. So one or both. Okay, so if your hand is still down, make sure that you ask the questions you need to ask to make sure that you get them right. All right, so there's something called an extraneous root when you're dealing with square roots. When you raise each side of an equation to an even power, you might introduce a root that is actually not a root, and it's called an extraneous solution. And the way you eliminate those is by checking your answers. So when you have an even root, meaning it's got to be a square root or a fourth root or a sixth root or an eighth root, something like that on either side of your equal sign, then once you solve, you want to take your answers and you want to plug them back in. Because they will appear to be answers, these extraneous roots. They look like they're good. You've done all of this work, you got an answer, but if you plug it back in, it doesn't work. There's no way to catch it ahead of time. So I wouldn't have had to do it on that last one because it was a cube root. So odd roots are fine. It's the even roots. If it's a square root, if it's a fourth root. So like A of the last one, okay, would be something in which now we know we need to check. And if when you plug it back in it doesn't work out, you just cancel it out. So if I had x equals 2 and then when I plug it back in it doesn't work, I would say that there's no solution. And they're called extraneous roots. So sometimes the directions on homework and stuff like that will say, make sure you check for extraneous roots, and this is what it means. So I'm going to take this equation. My square root's already isolated, right? That's a square root on the left-hand side, so what do? I square both sides. So I'm going to square the left, and I'm going to square the right. Now when I square the square root, it cancels out, right? So the left-hand side is negative 3x plus 33. And the right-hand side is 5 minus x squared, which is 5 minus x times 5 minus x. And what do we have to do with those? Boil them out. So this would be 25 minus 5x minus 5x plus x squared. Then I want to combine my like terms. So I've got 25 minus 10x plus x squared. Now, as soon as you see a squared and an x, what's it usually a hint that you're going to end up doing? I'm going to end up factoring these, right? So I want to move everything to the other side of the equation. I like to keep my x squareds positive, so I'll usually move everything from the left to the right in this case. So I would add the 3x. And then I would subtract the 33. And then I'm going to rearrange it so it's in order from highest exponent down to none. God bless you. So it would be x squared. You walk up minus 7x minus 8. And now we've got a factor. Yep. Put it back on the other side, you mean? So as soon as you see a squared and an x, you know you're going to have to factor. So you've got to get everything to one side. In order to factor and solve it, it has to be set equal to 0. It's the only way, because what we're basically saying is that if something in the left parentheses is 0, then the whole thing is 0, right? Because anything times 0 is 0. Anything in the right parentheses is 0, then the whole thing is 0. It doesn't work if it's equal to 8. It has to be 0. So now I would break down x, so x squared gives me x and x, and then I'm looking for the factors of negative 8 that sum to negative 7, which are what? Good. Positive 1, negative 8. And then when you're solving, I'm just going to split these so that they are each equal to 0, because if either one of those parentheses was 0, the whole thing would be 0. So I have two options here. X would equal negative 1, or x would equal 8. So as soon as I see a squared and an x, I know I'm going to factor. You want to get everything to one side. Keep it a habit to keep the squareds positive because it will make your life a little bit easier. Get them in order of highest exponent down to none, and then factor it. So here's where the extraneous root comes into play. We have to check these. So these are what we think are the answers. But when I take these numbers and I plug them back in, so I'm plugging them back in all the way at the beginning, the square root of negative 3x plus 33 equals 5 minus x. And I want to take first the negative 1 and plug it wherever there's an x. So negative 3 times negative 3 is 3, plus 33, square root of 36, which is 6. And then 5 minus a negative 1. What happens when you've got minus a negative? Changes to positive. God bless you. Does 6 equal 6? Yeah, so I know that this one is good. Negative 1 is good. And now I want to check 8. What's negative 3 times 8? Negative 24. What's negative 4 plus 33? 9. And the square root of 9, 3. 5 minus 8, negative 3. So does 3 equal negative 3? No, this is an example of an extraneous root. So 8 itself is an extraneous root. The only real root here is negative 1. And you don't know it until you plug it back in. So the ones that have a square root, you have to make sure that you check. Okay? And if it doesn't work, you just rule it out.